Okay, well, I think we are live. Hi everyone. I'm Chanukya. I'm the founder of AI Planet, and in today's session we have with us Haifeng from Google. He's basically a software engineer at Google Keras, and he's right now the project lead for KerasTuner and also AutoKeras. And before being a software engineer, he has done his PhD in computer science from Texas A&M University, and his primary research areas include AutoML, and he also co-authored a book on automated machine learning in action and with Manning Publications. And we are very pleased to have him today on board for delivering the session on simple, flexible, and powerful deep learning with Keras. So we'll get to know some really helpful insights for us to not just learn about Keras, but also implement it in real world production. And first off, thanks a lot, for joining in, and really pleased to have you. So looking forward to the discussion. I'll leave the floor to you now. Yeah, thank you.
Yeah, thanks for having me on AI Planet. I'm very honored to be here to give this presentation. And so let's get started.
Yeah, sure.
Keras and TensorFlow up to now have been 7 years in since its open source release, and it's now have around 3 million developers and the #1 most downloaded machine learning package on PyPy, and the third most started GitHub repo after Vue and React.js. Seems the JS community is more active, but TensorFlow is definitely the #1 in Python. And we have 4 billion devices currently running TF Lite, which is a TensorFlow small toolkit or model format for edge and mobile devices. And we have around 3,000 mentions in scientific papers every month. And we are very excited about these statistics. And also, there's another important survey from Stack Overflow, the developer survey 2022. TensorFlow has a relatively high percentage of developers who actually want to learn and use TensorFlow, which takes about 15% of the developers want to learn and use TensorFlow. And also, TensorFlow is widely adopted at Google, almost powering everything that's related to machine learning at Google, including YouTube, Waymo, Search, Photos, Gmail, Maps, Play, and Ads. Almost everything, every service you use with Google, probably you are using TensorFlow. And also powering a lot of other companies with the machine learning models like Netflix, LinkedIn, Spotify, and so on. There are many familiar icons here, I believe. And besides that, we also are benefiting a wide range of aspects of society, including disease detection and farm production, and also traffic efficiency, and many other things that we didn't mention here. And we are using machine learning on a daily basis right now. And our job is to anticipate transformative trends and facilitate them with our machine learning framework. And the trends we see here, there are mainly 4 trends we see. The first one is democratize and industrialize the machine learning. And the second one is large models train on more data. Currently, we all see like applications like ChatGPT and GPT-4. They're all very large models and with a huge amount of data trained. And also, machine learning is moving into the real world instead of just in the lab environment. And also, we have increased focus on privacy and safety. And as AI advanced so fast, many people have these concerns about their privacy and safety. So we will go through every one of these trends and introduce our solution to them. The first trend, democratization and industrialization of machine learning. We try to give access to every developer out there to the machine learning toolkit. And they can easily build and train models with us to build their own machine learning applications. So this we can describe this transformation like this, how machine learning has evolved into democratization and industrialization. Several years ago, like machine learning is still in a hero style, like one very good expert knows everything about machine learning, worked very hard to develop one machine learning application, and requires very high expertise for that. And it's a one-off effort. Basically, if you want to build another machine learning for another thing, you have to start from scratch again, and you basically can't use much of the work from previous code or research. But now we are like standardizing the process. It becomes a industry standard of how to make machine learning, train machine learning models, and put them to production. It is basically process-centric and collaborative between different roles and different teams. Roles, I mean, it includes software engineers and product manager and many domain experts, and maybe front-end engineers and UX and data scientists. They may not every one of them need to understand the details of these machine learning algorithms or models, but they can collaborate together to make this machine learning application without very high requirements of high expertise for machine learning. And this kind of become a more and more a standard practice that have a playbook that everyone can follow to develop their own applications, as long as it's the application is not too specific and kind of covered by today's machine learning research. And up to 2022, there were 25 million software developers, and about 12% of them have used TensorFlow and Keras. And around 7 years from now, we estimate the developers will grow into like a 45 million developer base. And how many of them would be using TensorFlow Keras? So our target is to make it around 50%. And at that time, around 15% of them will have postgraduate degrees, and most will use Python. So we have very high confidence to push this adoption of TensorFlow Keras to a next level. And how we are moving this machine learning from a craft style to the real industry. Here we summarize 3 pillars. The first is about UX design. We want people to do more with less expertise. And of course, we do that by designing a delightful API for people to use and to try to reduce the amount of expertise required, and they only learn what they need to develop their application. And the second pillar is ecosystem of reusable parts. I mean, basically they are pre-made models and pre-trained models. We will talk more about this part later. We also have some solutions for that. And the third pillar is ever more automation. So now we spend a lot of people on machine learning modeling and deployment, but we also need to pay more attention of ML ops. And also we try to automate the hyperparameter tuning process and also develop some AutoML tools to do these. And here's before we get into the actual Keras code, we would like to talk a little bit about the philosophies of how we develop Keras here. It's called progressive disclosure of complexity. Basically, people only need to learn what they need to use. If they want to use, they want to do a very simple application, a very simple neural network, and they don't have any customization, they can learn the most simple APIs. But if they want to develop a very advanced model or something, not very standard thing, they can also learn a little bit more. And basically, Keras is very flexible, and you don't have to learn all the details of it if you only want to develop a simple application. And here we have for cartoon characters here, we call it Professor Keras. So you may see this on the Keras website. Basically, the youngest one is it's a beginner guide. We use these marks on the tutorials and guides. So the youngest one is the beginner one, and this full-grown unicorn is like the advanced guide. Basically, you see these pictures and you know like what level of expertise is this tutorial and guides for on our website. And here's an overview of how you can progressively learn, or to what level you need to learn the Keras APIs. And first, the simplest is called standard usages. Basically, a sequential API, functional API. Basically, some easy ways to build models. You don't need to do much about models, just stacking the layers together. And the second level, additional functions, if you want to do, you can use some callbacks. For example, you want to visualize the entire training process. You can add a TensorBoard callback to it, or if you want to do early stopping to your training, or you want a checkpoint at every epoch, then you can do all these things with pre-built, built-in callbacks. And also, you can use do some customized objects. Basically, you can customize your layers, your metrics, your losses, and you can also implement subclass models. Everything here is open for extension. If you have an idea that is not addressed by the built-in modules, you can always extend those classes to develop your own solution. And actually, Keras is capable of doing more, almost anything you want, with a custom training loop with gradient tape. Basically, you can write every detail about how you train your model. And for example, we can implement learning to learn or new optimization algorithms with Keras, as long as you learn how to write a custom training loop. And here's a very simple example of a Keras. If you haven't used it before, you can get a taste of it. We are just implementing a 2-layer neural network with 3 neurons and 2 neurons. And basically 3 layers. The first layer just make the input tensor flat, just one-dimensional tensors with a batch. There are vectors with the batch dimension and the length of the vectors. This little shape consists of 2 numbers. And we also have 2 layers. One is length is 3, length is 2. And we specify the activation function here. It's very straightforward, right? And with this in mind, we can also make the model a little bit more complex, like this. This is a image segmentation model. Basically, we downsample. The input is an image. The output is also a map for the same size as the image. as you can see, the final output here, we segment the people in the picture with these red pixels. And so the input is picture, the output is this red shaped picture. And so the first thing we do is downsampling this picture to smaller, but with more number of channels. The tensor will have more number of channels, but smaller in size of the feature maps. And downsampling until it grows into this size. And again, we upsampling it to the original size. And we can easily write it with these. None of you don't need to implement any custom layers or something. You just stack these layers together with a for loop, basically passing in the input tensor, and you get the output tensor here. This is called the functional API. We do the downsampling here with the pooling layers, and here's the bottleneck at here. The bottleneck is here, the narrowest part, and we do some transformations and detection here, and we concatenate them together and do the upsampling, and finally get the output. So basically, with the sequential model and this functional model, you already can do a lot of things. And it's an ever-growing ecosystem of reusable parts in Keras. Basically, we don't just have the Keras as a PyPy package here for a user to use. We have many other members in the Keras ecosystem. And here we want to introduce KerasCV and KerasNLP. They are basically two domain packages for computer vision and natural language processing. And they consist of many reusable parts. They have pre-made models and pre-trained weights, and very flexible API. You don't have to download model in a chunk and only use that entire model. You can easily chop off some part of the model and further train it and tailor the model to your specific needs. Let's see some detail of it. So here's a brief overview. So the last few years of machine learning innovations have greatly expanded our understanding of what is possible with machine learning, from breakthrough performance in classic benchmark to the exciting new field of generative AI. So we will do both with these with KerasNLP and KerasCV. And at the same time, the state-of-the-art models have gotten increasingly complicated and often require expertise. Pre-training to expertise, even you just want to use some pre-trained weights or something like that. That's why we are introducing KerasCV and KerasNLP. They're the easiest way to deploy state-of-the-art model, pre-trained models or pre-made models for text and image classification and object detection, generative AI, and more in the TensorFlow ecosystem. So with these libraries, you have access to cutting-edge models with a simple and consistent API. Take a look at these two examples here. You can fine-tune a BERT classifier. On the left, you can see it's a fine-tuning BERT classifier, or generate images. On the right, a right example is generating images from a text prompt with just a few lines of code. And because these libraries are extensions of Keras framework, they feature the same easy-to-use API with Keras users. And if you are familiar with Keras, then you should have no problem in learning these libraries. You feel it's a breeze to use them. And so it have come to, you can expect the fully integrated key components of TensorFlow ecosystem with these packages, such as TPUs, D-tensors, XLA, and TF-Lite. So finally, these libraries feature a modular design that makes it easy to build custom workflows for any use cases. And let's explore both libraries in more detail. So first, the KerasCV, what can you do with KerasCV? So here's an example. Let's start our tour of the unified KerasCV and NLP modeling API with an image classification task, which is very basic. In this example, we would like to classify the images as cat or dog. You can think as negative or positive labels. And the highest level model in KerasCV and NLP is called a task. A task like image classifier we imported here as a task. And it's a Keras model consisting of a backbone submodel and a task-specific layers required for solving the specific problem. So backbone models, in turn, are a set of reusable layers, generally pre-trained on a separate task to extract highly informative features from the input data, greatly reducing the amount of label data and compute resources required to get competitive performance on your task. So here you can see we have a ResNet backbone, and in this example, we use ResNet architecture for our backbone to load models with pre-trained weights in KerasCV and NLP. So we use the from preset constructor with the name of a preset. Here you can see the backbone equal to something for the preset, right? In this case, we use ResNet 50 ImageNet. It's a 50-layer ResNet model pre-trained on ImageNet classification, and you can find a list of all available presets in the class doc strings or on the Keras.io website. So we basically have a lot of presets, some of them with pre-trained weights and some of them don't. And once we've created our backbone model and we pass it to the image classifier constructor along with a number of classes we'd like to predict. After that, compile and fit model as usual, like any other Keras workflow, and you're ready to go. And here's another task in KerasCV about object detection. So this is a significantly more complex task than image classification because the model can detect any number of objects and must predict a class and a bounding box for each. So you see these bounding boxes on these pictures, right? That's the prediction target. And in this example, the blue box and the classes are ground truth labels for objects and image, while the orange boxes and the classes are inferred by a KerasCV RetinaNet model. So RetinaNet is popular for object detection tasks. And despite this added complexity, creating an object detection model with the RetinaNet architecture is very similar to image classification. Well, we again choose a pre-trained ResNet 50 backbone, use the preset constructor. And the main difference is requiring labeled bounding boxes in the training set and specifying the bounding box format in the task constructor. So you see here we use XYWH, right? This is very important in the configuration. And after that, also compile and fit model like any other Keras workflows, and we're ready to go. And data augmentation is also a critical pre-processing step necessary to maximize the accuracy in computer vision tasks. In order to avoid overfitting to the lighting and cropping and other particular for the training set, it is important to rotate, perturb, and even mix together original images to increase the robustness of the training objective. For example, these flowers in our left panel are the original images, and the lower left panel are augmented versions of these flowers by KerasTuner. So they're a little bit different, as you can see. KerasTuner offers a wide variety of augmentation layers, all in simple API, and can transform classification labels and object detection bounding boxes along with original images. These include a random flip for rotation, random augment for intensity perturbations, and cut mix and mix up for creating opposite images, and many more are in there. Simply combine your desired augmentation layers in a Keras model and map over your dataset before training a model. And just like this flower dataset on map something, then we have got a new dataset output. Then you can use this dataset to train your model. Here, we have another example of generative AI. KerasTuner provides that simple interfaces to both the Stable Diffusion and Stable Diffusion version 2 models to generate novel images from your text prompts. So instantiate a Stable Diffusion task with the desired output image size, and then call, which is 512 here, and call the model's text-to-image method with a prompt and number of output images. So here we want output 3 images, and the text prompt we use a photograph of an astronaut riding a horse. So you can see the results on the left, pretty good. And we're constantly adding more generative AI capabilities to KerasTuner. Here are some advanced features we already support. Textual inversion on the left is a method to teach Stable Diffusion models specific visual concepts via examples. For example, we can provide a set of input images to teach a model about our teammates' cats, and then ask him to be visualized as a fantasy character. And on the right is a prompt-to-prompt method. Modify the prompt to be to input to a Stable Diffusion while keeping the image visually consistent. For example, after asking Stable Diffusion to generate a photo of a dog with sunglasses, and we can replace a dog with cat and to get a visual similar image of a cat wearing sunglasses here on the lower right corner. And if you want to learn more, welcome to visit our website on keras.io. We have more developer guides and examples there. And let's move into Keras NLP then. So let's start by training a sentiment analysis classifier to predict whether movie reviews are positive or negative. We instantiate a BERT classifier. Task model is a task model using the from preset constructor. So one difference from KerasTuner is that Keras NLP task models like BERT classifier include preprocessing by default, because natural language tasks usually start from a whole sentences strings. So we need these preprocessing steps. This means that you can pass raw strings at both training and serving time without worrying about using correct tokenization methods and packing methods. And for this reason, it is best to call from preset on the test model itself rather than passing an explicit backbone model. This will automatically give you a matching preprocessor class, which will tokenize and pad the input text to match the expectations of the backbone classes. So the backbone which is here we actually use BERT backbone, and the preprocessing part for BERT need to match with each other. This is very important. So in this case, we choose BERT base English uncased, which is pre-trained weights. For BERT, they use very large architectures and lowercase English data. This backbone has been pre-trained on gigabytes of text data, and to understand the meaning of the words in context and extract more information from our label examples. And you can find a list of all available presets, again, in the doc strings of the classes or on our website documentation. After fine-tuning our model on data set of sentiment labels, movie reviews from IMDb, we can predict the sentiment of 2 new movie reviews here. We see that our first review, "What an amazing movie," is given 99.6% the probability of having positive sentiment, while our second review, "A total waste of my time," is given almost the same probability of having negative sentiment. So it's pretty high accuracy. And Keras and OP also offers text generation using popular models such as GPT-2 and OPT. Fine-tuning a text generation model as easy as classification. So simply pass a data set of text that you want the model to imitate, and preprocessing will be handled automatically. So causal LM is a task model that predicts each token in an input sequence given all the preceding tokens. It is the canonical approach to training generative text models that can predict new tokens given a user prompt. In this example, we had a pre-trained base GPT-2 model using the from preset constructor, and fine-tune it on 300,000 news articles from CNN and Daily Mail. And after that, we compile and fed the model like any other Keras workflow. So causal ML tasks come with generate method, like you see, and allow you to specify a prompt, sampling strategy, and maximum output length to generate new text. Here we generate the start of a news article about snowfall in Buffalo, New York. And so it says expected snowfall in Buffalo, New York was expected to reach 2 feet by the end of the day, and according to the National Weather Services. Yeah, this is the generated text from the model. And again, this all these APIs of Keras CB and LP follows the philosophy of Keras APIs, progressive disclosure of complexity. And let's see if we want to do more with these models, what we need to do. So we accomplish this by building up our highest level APIs from a set of lower level modules that are as well documented as and easy to use as all of other models we've shown so far. For example, suppose that your dataset includes relatively short text segments and training requires many passes through the data. In that case, the built-in preprocessor and BERT classifier may not be a good fit for you, since it will pad all the sequences to the maximum length of 12 tokens and recomputes the preprocessing in every epoch of training. For these reasons, you don't have to fork our code or start from scratch. Our BERT classifier is built from customizable BERT backbone, BERT preprocessor, and BERT tokenizer classes. And each of them have their own presets. You can use them separately instead of like only use the things with the BERT classifier. So how do you customize the preprocessing? So to avoid invoking the preprocessor twice in your workflow, simply pass preprocessor equal to none and to the task constructor and compile and fit model like any other Keras workflow, and you're ready to go. So and build a transformer from scratch. We have an example here, and in case you need even more flexibility. So want to build your own custom transform-based classifier from scratch, you can use Keras LP, which offers all the necessary primitives to build a unique LP model in just a few lines of code. These primitives are very simple and same methods we use to build the state-of-art models, and you've already seen. So using the Keras functional API, the first step is to creating new models and declaring the input tensor. So if you are familiar with Keras, this is you already know this. And we then pass this sequence to an embedding layer that learns a unique vector representation for each token ID and sequence position. So returning the sum of each token in a sequence. And when we pass the embedding output to a stack of configurable transformer encoders, here we using the for loop that apply a sequence of multi-head attention and feed-forward layers to input. The output of the stack is our final sequence representation. So to produce a single classification output for the token sequence, the common practice is to put a placeholder token at the beginning of each sequence and pass this token representation as the input to a feed-forward layer with the same number of outputs as the classes to predict. So as with any Keras model, we pass the functional inputs and outputs to the constructor of a model instance and compile, fit, model like any other Keras workflows, and we are ready to go. So that's for the Keras CV and LP with pre-trained and pre-made models. We also want to increase the automation to make machine learning process, modeling process even simpler. So what we're going to do here is hyperparameter tuning and architecture search, and also a little bit of AutoML to boost the efficiency of the engineers. The solution we have here is called KerasTuner. It is for automated hyperparameter tuning. Well, with KerasTuner, you can define by run dynamic search spaces. You don't have to define all the hyperparameters all in advance. If you're not familiar with hyperparameter tuning, basically they're just when you're not sure which hyperparameter is the best for your machine learning model. For example, you're not sure which optimizer is the best. You want to use Atom or just the standard SGD or something. You can make it a hyperparameter and these things you need to tune them to find the best hyperparameter. And other examples like the number of layers or the number of neurons inside a layer, and these can all be hyperparameters to tune in order to achieve the best performance of the model. And in KerasTuner, we have some built-in strategies like hyperband, which is pretty popular for hyperparameter tuning, and we have Bayesian optimization, which more classic, have been used for tuning a lot of things for many years. And we also have some vanilla solutions like random search and grid search. You can use them based on your use case, or you can also define your own strategies with KerasTuner. KerasTuner is open for extension and customization, and it's also capable of doing a large-scale distributed search. You can do parallel tuning, running different models, training different models with different hyperparameters at the same time. And here is a short example of Keras code. We have a Keras sequential model with a dense layer, 33 neurons inside. And if we want to tune the 32 here, what shall we do? we just turn it into a KerasTuner component, HP, give it a name, give it a lower bound, upper bound, and the granularity here to it, and run it. We are ready to go with KerasTuner to tune this hyperparameter. And we just initialize a random search, for example, random search tuner, and we just call search with it. And the parameters here we pass to search is exactly the same thing you pass to a Keras model .fit. So as long as you know how to use Keras, there should be no problem migrating to use this KerasTuner for hyperparameter tuning. And KerasTuner basically works in the following way. You can see it as a tuning loop. The first step is to train the model, and second step is to evaluate the model. You define the metrics how you want to evaluate the model, or use like just the default. For example, classification, we just use classification accuracy or the validation loss for it. And the third step is based on the evaluation results, whether this set of hyperparameters is good or bad, we make changes to the hyperparameters values and go back to train the model again. And Andrew Wu once said AI is the new electricity, but today you can think it's largely not ready. AI is still far from electricity for us to use. So how do we use electricity today is like whenever your phone's battery is dead, you just plug into the wall. You don't care about how these power are generated or how they're delivered to your house. But how to use machine learning today? You have to go through a long list of books or curriculums in order to learn all the models and algorithms and learn all the frameworks, and you need to learn programming and a lot of overhead in order just to build a simple machine learning model. It's not easy. But the good news is we have AutoKeras to help you build some simple models for machine learning with very simple code in API. This is also called AutoML. We hide all the details of it. Here you can see a very simple example. So it's image classifier. You just import AutoKeras and create an image classifier, and you just pass in your training data, X and Y. And after some time, it searched a bunch of models, and you're ready to make the predictions for the tested data set. It's very simple. And so you can pass KerasTuner arguments to the image classifier, and also Keras arguments to the fit and predict. So it fully supports all the features of these KerasTuner and Keras for training and initialization. And also you can export this model as a Keras model and save it to the disk, and it is ready for deployment with the TensorFlow ecosystem. And we actually have 6 different tasks from different type of input data and to different tasks like classification and regression. And we also support multi-model and multi-task training. So you can have image input and structured input at the same time. For example, a picture of a house and the different attributes of the house, like the area and the number of rooms and address. And you may want to do regression and classification together, like what's the price of the house, and classification like how many people should be living in this house. And it's just, again, very simple. You just define the inputs as these 2 kind of inputs, image and structured inputs, and outputs as a list of these task has and regression and classification, and you wrap it into AutoModel, and you're ready to go with the fit with the actual data set. And notably, you can pass the metrics that you desired to output for this regression hat as an argument to it. And for advanced users, if you already know like what type of models you want to use, you can just define your own architecture, high-level architecture. You don't need all the details of it. You can define high-level architecture like this, with all the built-in blocks like a RESTnet block, exception block. We have all the predefined hyperparameters inside these blocks. You don't need to define them yourself. You just use them directly. And also, each of the blocks support a wide range of arguments to configure. So usually, if you know the configuration, you can pass in the configuration to reduce the number of hyperparameters to make the search more efficient. And the other trend, another trend is larger models training more data. So basically, this is an example of TensorFlow, but the details are not important. Basically, this runs on a single machine. This is the code of TensorFlow runs on a single machine. But what if you want to run it distributedly? What you need to modify here? So you basically just add these two lines of code. One is the distributed mirror strategy, and open the scope of it, put a code inside of it, and that's it. You can run it in distribution. And also, that's called data parallelism with the distributed strategies. Here, we also want to do model parallelism. For example, you have a very large model, and it doesn't fit in the memory of a single GPU. You need to split it among different CPUs and GPUs. And what you do is with dtensor, you can actually split the tensors like this onto different devices very easily with this simple interface. And with this, you can build very large models that scale up to multiple machines, multiple GPUs. And with the data parallelism, we just introduced the distribution scope. You can train with very large data for this very large models. And also, we are moving into the real world. We're trying to deploy machine learning on billions of mobile devices and embedded devices, edge devices, or even in the browsers. So what solution we have for that? Basically, we have two toolkits here. One is TensorFlow Lite, one is TensorFlow JS. So TensorFlow Lite is ready for mobile devices, embedded devices, and TensorFlow JS is using JavaScript. You can deploy them on browsers and any device with a browser. And we can even do on-device learning with TensorFlow Lite. And we have 400 million monthly active users of TensorFlow Lite in Google Play, and 20 billion daily inferences, which is pretty amazing. And with these tools, we actually have some very good applications for it. For example, we have a magic eraser in Pixel phones. You can erase out the things or people in the picture that you took. And also another example is here a 3D printing. When it fails, it output a bunch of spaghettis. When you see this object model output a lot of spaghettis, you know like the printing failed. And TensorFlow JS, machine learning in JavaScript, it has lower latency, high privacy, and lower serving cost. And also support Node.js for server-side and IoT devices. And we have applications like face mesh, so you can easily get these face detection applications. And also an interesting application is to try on these colors for makeups on the website directly. You don't need to download any app, just directly in your browser. And about a segmentation in the browser, and no server side as well in real time. And also, there are some third-party very exciting applications like Include Health, build this for people to do exercise, to do this using TensorFlow JS and TensorFlow Lite. And also, people have increased focus on privacy and safety. So managing the privacy risks and social risks of ubiquitous deployment of machine learning is also a very important topic today. So how Google does it is we have our own principles, which you can see here, and be social beneficial and avoid creating or reinforcement unfair biases. Basically, 7 principles in total to ensure we are going to the right direction with AI. And we have a list of important questions to ask while we are trying to develop a responsible AI application. And besides that, we also have a toolkit to ensure that our AIs are responsible. For more information, you can visit tensorflow.org responsible AI for that. And so basically, we are making a lot of AI applications that need to be responsible, that have a real impact on the world. This is very important to Google and to TensorFlow as a machine learning framework. And so here's a quick recap of what we've looked into today. So for democratizing and industrializing machine learning, we learned Keras' principle of API is a progressive disclosure of complexity. You only need to learn what you know, and only you write just the right amount of code for what you need to build. And also pre-made and pre-trained models with Keras NLP and Keras CV, and hyperparameter tuning with KerasTuner and AutoML with AutoKeras. And also for larger models trained on more data, we have data parallelism with TensorFlow.distribute.strategy. Just 2 lines of code, you're ready to scale your machine learning code. And also model parallelism, you can make one model to distribute it on multiple machines and multiple GPUs with dTensor. And machine learning also moving into the real world, we can deploy our applications on edge devices and mobile devices with TensorFlow Lite, which will build your model into a smaller executable. And also machine learning in the browser, a lot of interest. We see a lot of interesting applications with TensorFlow JS, which deploy these machine models with JavaScript in your browser. And also, we have an increased focus on privacy and safety while we are building these machine learning applications, especially Google's AI principles, questions, and toolkit to ensure the responsiveness of AI. And here are some resources. If you would like some further reading, you can visit Keras.io for all the documentation and tutorials of the library we introduced. And if you find any bugs or you have a feature request, please go to our GitHub repo to submit that. And also, you're welcome to participate in the TensorFlow forum for any questions to discuss with the community members. And we are also holding regular community meetings, and we will be announcing those in this forum for you to participate. All right, that's all for my presentation, and thank you, everyone.
Hi, Haifeng, and thanks so much for the session. I think it was amazing in the first place. I think we have a few questions as well. Personally, I learned a lot as well throughout the session. So I'll probably start picking a few questions. Maybe I think before I pick some questions, I think someone said it's an interesting event to join and learn something from a rainy Saturday on LinkedIn. But anyway, so let me just go to this first question, Val. And so it is understood there is a inferencing API. Actually, he corrected it later. It's inferencing API. But do we have tuning API for SOTA models on Keras For example, is there a tuning API that would allow to tune stable diffusion?
We don't have a built-in tuning module for Keras CV for that for a stable diffusion module, but you can use combined with Keras CV and KerasTuner to tune that. It shouldn't be hard. And we have all the available arguments for you to specify in Keras CV for the stable diffusion. You just make them into KerasTuner hyperparameters and just tune it with KerasTuner. It should be pretty easy.
Okay, got it. A follow-up question, I think, is this computationally less heavy or super heavy? I mean, when it comes to using the Keras APIs. So,
Yeah,
yeah.
I guess it's super heavy, especially for large models. So if you want to do a hyperparameter tuning with them, it means you need to train at least several models to get the best hyperparameter. So prepare enough number of GPUs and do like parallel tuning with it. And if you
Okay.
just want, you don't have enough computational resource, just to specify the right algorithm. For example, Bayesian optimization, which converges fastest and based on a small number of samples. So we do need some computational resources for that.
Got it. Got it. Any rough estimate,
Oh,
what is it like? Let's say, if you're talking about some large language model or a stable diffusion, how heavy it would be? I mean, do we need to use some GPUs like NVIDIA Tesla or A100s, or
yeah, it depends on how large the data set is.
yeah,
So if you want to, I guess it can also be done just to some further training with a
okay,
pre-trained one. And on a single
got it.
GPU is more than enough. But if you want to train it from scratch, then you need
Yeah,
several GPUs probably to be efficient.
got it. Understood. And a quick,
Sorry, I see another one. It said it's a typo. Inferencing APIs.
yeah, I mean it was meant to be inferencing API. I think I corrected that in the question itself.
Okay, cool.
So yeah, I mean, so I think that we covered. So I think this was very specific to Keras. So it is a comparison between Keras and probably PyTouch. What is the flexibility that Keras offers in terms of execution, and also maybe, yeah, I mean, maybe you can throw some light on that. Yeah.
Yes. So, while you want to do very fast inferencing, we probably need is to enable the XLA part on it. So XLA is a very powerful graph optimization for these neural networks. And so to enable it, that you need to pass argument to the compile function of the Keras model, JIT, enable JIT just-in-time compile equal to
Yeah.
true, and then it will actually boost the inference. And we also have some toolkit to just optimize the inferencing time for that. And it's definitely much faster than any like eager mode or so.
Got it. I think this question is related to your to the TensorFlow Lite, I guess. Is it possible to deploy something like Stable Diffusion or any LLM or vision model on TensorFlow Lite on devices and expect it to run? And there is a follow-up question based on that. Can I use it on a smart lens powered by AI where it is expected to run speech to text to action and vision models? And most importantly, security is core to this, plus speed is equally important. I think this is in reference to a smart lens that can be powered by a bunch of vision and also speech to text models. So
Um, Currently, we don't have a module for that. Probably not in Keras CV or Keras NLP, but I do believe we have all the available backbones for that. So
yeah,
what you need to do is write a bunch of has and connection networks and directly use these backbones together. Although we don't have them, it shouldn't be hard to reuse the parts that you need from these libraries to build that.
got it, got it, understood. And I think this question, I think one final question before we sign off. So I think this question is related to tuning, but I think you already addressed. Can Keras
I
API?
haven't thoroughly addressed the inferencing and
Yeah,
like fine tuning part, right? So
Yeah.
it's you can do both, hyperparameter tuning or fine tuning. And the fine tuning is much easier. Like I introduced in the example, you just import a pre-trained weights, and you can directly do inferencing if the same number of classes you have, and you can just further fit with your uh, data set with a small learning rate and a small number of epochs. You're ready to go with that. It's super simple.
Got it. Cool. Great. Perfect. Thanks. Thanks so much, Haifeng. I think it was great talking to you and also hearing from you. And also I mean, like just final words on anything that you want to. I mean, like how did you yourself start your data science journey? I mean, like maybe if you can throw your light on your data science journey, on how your progression has gone through, and then probably if you can share some piece of advice to the community, we'll be happy to learn from that. Yeah.
I'm not sure as it would be good advice, but I can definitely share my experience.
Yeah.
So I just started by my journey by doing my PhD. I applied a wide range of uh, professors in areas, and finally I chose from them. I feel like AI and data science is like the trend of the future, so I chose this in 2016, and then I started learning a lot of things in this field, and then I built AutoKeras as my PhD, one of my PhD projects, and that got adopted to the Keras ecosystem. So I got hired to Google to continue to develop this ecosystem. That's that's basically my journey in short. But as long as people really want a high professional life in in machine learning or data science or AI, definitely a PhD is a good advice, but it's definitely not an advice for everyone, right? So
Right.
if they have a passion, they're welcome to do a PhD, and this is a good way to have a high profession.
True, absolutely, and especially, I mean, like one thing that I starkly remember in the session is about AI is called the new electricity, but we still are struggling to how to use it,
Yeah,
right? I think especially when we talk about some of the large tech companies, they have a lot of resources, access to supercomputing facilities, and all. It's easy to train and also develop some large language models. So how do you see this being democratized to SMEs so that they can start innovating, or even make it more feasible for them to use some of the large models to not just use but also to train for their own use cases? How do you see this evolving? I mean, what do you see the next trajectory to make it more democratic to all
yeah.
businesses and also industries? Yeah.
Yes, I believe large language model are great, but they are not applicable for every use case of AI.
Yes.
And the large language model they are very large and resource consuming, and they probably will remain in the large corporations on the cloud. It just open up a cloud API for you to call. So
Yeah.
it's not suitable for many applications just on the edge without internet access. And at the same time, large language models are general models. They are very general, so they may not have the best performance at a very specific tasks. So I
Yeah.
believe for AI really to industrialize and democratize, we need a lot of different smaller models, and for different applications specifically for each application. And that will really make AI more democratized. And to enable these things, that's why we are making these toolkits very useful for users with less expertise, but they might be domain experts for a field that potentially can use AI to like revolutionize the field. So they
Absolutely.
should be able
Yeah.
to use our tools to do that.
I agree. I agree. Totally agree. And I think right now, AI on cloud is a largely solved problem where, people are able to deploy and also use some of the large models or even APIs that are provided by different cloud services, including GCP, AWS, and Azure. But when it comes to, yeah, I mean, when it comes to AI on edge with privacy that you specifically specified about, how do you think, because right now, some of the large models we can't really execute on edge devices, of course. I mean, not the large language models, but even some of the models that are quite helpful, which are very specific to certain use cases, it's still hard to deploy, or you have to compromise on the quality or whatever it is. I mean, you have to do a trade-off between the performance and quality and other things. So how do you see that panning out in a long run? And are you doing something on those lines?
I believe we are mainly relying on the TensorFlow ecosystem to do this.
Yeah.
Like what I introduced, TensorFlow Lite is doing that. We
Yes.
also have another toolkit called Model Optimization Toolkit, which were not in the slides, but very useful. They reduce the number of weights or the number of parameters in the model.
Yeah.
They try to keep up with the performance. I believe now the solutions are mainly like this, but with the advance of both these toolkits and hardware, I believe we are like although then not fast progress, but we are making progress in these applications.
Sure, absolutely. No, I mean, thanks a lot for the amazing talk, and looking forward to more. And thanks a lot. Keep doing the great work, and also on the other side, thanks a lot for everyone who has joined in, and have a great rest of the weekend. Take care. Yeah.
Thank you.